Now we're going to look at some theorems that are related to divisibility. So in math, theorems are things that have already been proven to be true. So we can use them all the time as examples of things that are true and to help us prove if other statements are true. So there's three main ones that they mention in the textbook. The first one says, and for all of these theorems, A, B, D, and N, they're all just going to be whole numbers. So any generic whole number. So the first theorem says if D divides A, so that means D divides evenly into A, then D will divide into any multiple of A. So that's true all the time. So let me show you an example. If 5 divides 15, we know that that's true, right? 5 divides evenly into 15. Then 5 is also going to divide into 30 because 30 is a multiple of 15. So if this is your A, if this 15 is playing the role of A, then 30 would be 2 times A. See how that's a multiple of 15? So if we know that 5 divides 15, it's a given that 5 is going to divide 30 because 30 is a multiple of 15. So that's what theorem 1 says. Theorem 2 says if D divides A and D divides B, then automatically D will divide the sum of A and B or the difference of A and B. Like it's a given. If a number divides into A and a number divides into B, it will divide into their sum or difference. So I'll give you another example to show that it's true. If 5 divides 20, we know 5 divides 20, and 5 also divides 15, then 5 will automatically divide 20 plus 15. This 35 is 20 plus 15. So 5 will divide their sum. We know that's a given. And you can read it. Once you put numbers with it, you can see it makes a little more sense. Let's try the difference. We know 5 divides 20. We know 5 divides 15. So then stemming from that, 5 will also divide their difference. 20 minus 15 is 5. And 5 does divide evenly into 5. It divides in there one time. So that's theorem 2. Theorem 3 says if D divides A, but it doesn't divide B, then D is not going to divide the sum or the difference. So basically it's an all or nothing. D has to divide A and B if it's going to divide the sum or difference. So if it divides one but not the other, it's not going to divide the sum or the difference. So for example, 5 does divide 20, and we know that 5 does not divide 8. Like 5 does not divide evenly into 8. So we know that from this theorem, 5 is not going to divide 28 if you take the sum. 5 divides 20, 5 does not divide 8, 5 is not going to divide 12, and 12 is their difference. Right, so that's what that theorem tells us. So let's do some true and false, kind of using these theorems. If any of these theorems help us prove true or false, we'll state it. So for all of these examples, A and B, the letters that you see are just going to be whole numbers. So the first one says, if 3 divides A, then 3 will divide 5 times A. So that's saying 3 divides a number, 3 divides a multiple of that number. Well, that's exactly what theorem 1 says. So this is theorem number 1. I'll abbreviate that and we'll say this is true. And I don't even have to put any examples to prove that it's true. It's just theorem 1. Okay, how about the next one? The next one says, if 5 divides A and 5 divides B, then 5 will divide AB. So this is their product. The theorems talked about sums and differences. Let's see if this one's going to work. 5 divides A, 5 divides B, 5 will divide their product. Let's see. Let's just pick some numbers. Like 5 divides 10, and another number that 5 divides is 15. We know 5 divides 10. We know 5 divides 15. Does that mean that 5 will divide 10 times 15? 10 times 15 is 150. Right? This is 10 times 15. Is that true? Does 5 divide 150? Absolutely it does. So it looks like this is true. You would really need to sit down and do several examples to show that it's true. But I can tell you if 5 divides into A and B, then if you just multiply A and B together, we already know 5 is going to be dividing into both of those already. So it should divide into their product. So there's no theorem for that, but it is true. Let's try the next one. If 7 divides A and 7 divides B, then 7 will divide their sum. Well, yeah, that's exactly what theorem number 2 says. So I will say theorem number 2 for that one. That one is also true. And we don't have to say anything else, it's just theorem 2. All right, if 3 divides the sum of a and b, then 3 has to divide a and 3 has to divide b. Okay, so that feels like theorem 2 a little bit, but it's theorem 2 in reverse. So the question is, does the theorem work in reverse? Well, let's see. Let's find some numbers for a and b. See, something that I know 3 divides 12, for example. I'm going to break this up. I'm going to say break into 10 plus 2. That's one way that you can get 12 if you add 2 numbers together. I'm just picking 2 random numbers that add up to be 12, like 10 and 2. So does this mean that 3 divides 10 and 3 divides 2? Is that a true thing? If we say 3 divides 12 and 12 is this sum, does that imply that 3 has to divide 10 and 3 divides 2? Well, does 3 divide 10? No. Does 3 divide 2? No. So it looks like this thing is false. It all depends on how you break up the 12, though. If you said that 12 was, say, 9 plus 3, and then you said, okay, 3 divides 9 and 3 divides 3, if that was the example that you chose, you would think it was true. But we have to find a counterexample. We have to find an example that shows that it's not true. So, sorry, I forgot to move the paper up. Here's the 9 plus 3. That one works if you break 12 up that way. But if you break it up into 10 and 2, it doesn't work. So overall, the statement would be false. All right, let's try E. If 2 divides A and 3 divides A, then 6, that's 2 times 3, has to divide A. Well, what's a number that 2 and 3 both divide into? Like, I don't know, 12? 2 and 3 both divide 12. So what if I let A be 12? If 2 divides 12 and 3 divides 12, does that imply that 6 divides 12? Well, yeah, because if 2 goes into 12 and 3 also goes into 12, then that means the 2 and the 3 are both dividing into the 12. 2 times 3 is 6. That has to be true. Has to be true. All right, how about F? It says, if 9 does not divide a number, then 3 also does not divide the number. So let's see, what are some numbers that 9 does not divide into? For example, like 15, for example. 9 does not divide 15. Does that imply that 3 does not divide 15? Well, wait a second, 3 does divide 15, so that can't be true. So just because 9 doesn't divide into it doesn't necessarily mean that 3 won't divide into it. If you did 9 does not divide 11, also 3 does not divide 11, so that would be true. But that's just one statement. You got to try like a bunch of numbers. And I found one right here that 9 does not divide, but 3 actually does. And you know, the reason they're asking this is because 9 is 3 times 3. So there's some numbers that 3 goes into, but 9 doesn't. And this one's asking if 9 doesn't go in there, then is it automatically that 3 doesn't? And that's actually not true. So false. These are kind of tricky. It's hard to come up with counterexamples sometimes. All right, if 8 divides a number, then 4 and 2 will also divide that number. So let's see a number that 8 divides into, like 8 divides 16. Does that mean that 4 will divide 16 and 2 will also divide 16? Well, 4 does divide 16 and so does 2. I think it has to be true because 8 is 4 times 2. So if 8 divides into a number, by default, 4 and 2 are automatically dividing into that same number. So this one is true. Now the last one, we're going to do this in reverse. If 4 and 2 divide the number, then is it a given that 8 is going to divide the number? Well, depends on what number you pick. If you pick 16, 4 divides 16 and 2 divides 16. Does that mean 8 divides 16? Well, that would be true because 8 does divide 16. What about the number 20? 4 divides 20 And so does 2. 2 divides 20. Does that mean that 8 divides 20? Oh, no, that one doesn't. And as soon as you find one where it doesn't work, the statement's false. So sometimes statements work one direction, but they don't work going back the other direction. It just depends. So this is divisibility theorems and how to do some true-false with divisibility rules.